Hey, today I'm going to share with you a few things about Chapter 1, Section 7, three-dimensional figures. Last time we identified and named two-dimensional figures, and now we're going to identify and name three-dimensional figures, finding surface area and volume of said figures. Look at all this vocabulary. I got this from the book. Believe it or not, you can read a geometry book. Let's see here. So a polyhedron is a solid with all flat surfaces that enclose a single region of space. Okay, and each flat surface or face is a polygon. So in order for you to call something a polyhedron, every face has to be a polygon. We learned about polygons in Chapter 1, Section 6. We've got edges, which makes sense, and then each little corner is actually called a vertex, where three or more edges intersect. Okay, the exact definition is there. Here are two examples of polyhedrons. Here is a prism. A prism is a polyhedron with two parallel congruent faces, and they're called the bases. The base isn't always what it sits on. It's the shape that could be repeated and stacked upon itself in order to create the figure. The two bases on this prism are 1, 2, 3, 4, 5 are pentagons. Okay, and then the faces are rectangles on this prism. A pyramid is a polyhedron that has a polygonal base and three or more triangular faces that meet at a common vertex. Notice how this base doesn't have another base on the other side that's parallel to it. And all the sides are triangles, and they all meet at one point at the top. This is not a cylinder. This is a cylinder. It is not a polyhedron because there's curved surfaces. A cone is also not a polyhedron, and a sphere. Those are examples of things that are not polyhedrons. I didn't assign you to do these because I thought it was very excessive to be naming all the faces, but I wanted to just show you this example. Okay, it asks you to determine if it's a polyhedron, identify the name of the solid, and name all the bases, faces, edges, and vertices. That's the part that's the reason I decided not to assign those problems. But this is a good example, and here we go. The solid is formed by polygonal faces, so it is a polyhedron. And the bases are hexagons. So see this base, KLMNOP, is parallel to EFGHIJ. Those two bases, those two faces are parallel and they're the same shape, so those are considered the bases, and they're hexagons, and thus the name of the prism is hexagonal prism. Okay, and this is how you would name all the faces and all the edges and all the vertices. So notice that this does not have two bases that are parallel. It's made up of lots of triangles. So this one and the next one are two that I see people get confused. So I left them in as examples. This is a triangular pyramid because the three faces that meet at the top at point X, JXK, XKL, and XLJ, those would be the sides, and the base would be JKL. So the difference between those two, this one's a triangular prism. The two bases are triangles and all the sides are rectangles. They do not meet at a common point at the top, so it's not a pyramid, it's a triangular prism. A polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all of the edges are congruent. There are exactly 5 types of regular polyhedrons called Platonic solids because Plato used them excessively, and these are found in the book. I included it as a fun fact. Surface area and volume of these common shapes. Here's a prism, regular pyramid, cylinder, cone, sphere. Notice that the T is for total surface area, and that means it includes the area of the bases also. Sometimes they'll ask you for lateral surface area, and that is only the sides without including the bases. The volume, V is for volume. A capital B is the area of the base. So for these prisms, on a rectangular prism, you just have to pick which two rectangles are the bases, and you find the area of one base and you multiply it times the height. On a regular pyramid, there's only one base. You need to know what this little cursive L is. It's called the slant height, and I can illustrate it best by looking at this cone. The slant height is along the side of the cone, and the actual height is like imagined inside the shape, and it goes from the center of the base to the top of the solid. And that you need to know the difference between slant height and height of the solid in cones and pyramids. When I say the top, like in this case, it's the bottom, right? But it's where the sides all meet, and cones don't have sides that meet. It's one curved surface. So it's the top, it's the point of the cone. In a pyramid, it's the point of the pyramid, I guess you could say also. Yeah, it's where the sides all meet. R is for radius. Yes, there are thirds involved when you're finding the volume of a pyramid and a sphere, which is basic, in a cone, which is basically getting the answer and dividing by 3. Okay, I have included some pictures that I found on the internet, obviously, and I really like showing an image of, okay, blast from the past. These are CD-ROMs and they're stacked, and if you think of it as a solid without the thing in the middle that's holding them in place, it's a cylinder in shape. And so I kind of think it helps you realize why you, to get the volume, you find the area of the surface multiplied times the height. And to find the total surface area, you take 2 pi r, which if you go back to chapter 1, section 6, that's the circumference, and you take that times the height. So in other words, you're kind of like finding the area of the side of the cylinder by multiplying the distance around the outside of it, and you're just like adding it up, like how high it is. And that's the reason when you multiply something, when you add something repeatedly and repeatedly, it's the same as multiplying. So circumference times height will give you the area of the side of your cylinder, and then plus you need 2 times pi r squared. Well, the area of the top and the bottom of the cylinder, they're circles. And this fun shape is a prism, and it's a triangular prism. If you could just like remove the sandwiches from the picture, but of course I wanted to leave the sandwiches in the picture so I could illustrate it. So you can see that the top of the sandwich is triangle and the bottom triangle. If you look at the sides, this side right here, from here, oops, I accidentally clicked and it went away. Hang on. Here we go. From here to here to here, that could be estimated as a rectangle, okay? So the prism that they had in the formula chart was a rectangular prism. This is a triangular prism. So when they say capital B times H, they say to get the volume of a triangular prism, the area of the base is a triangle. So you would need to know the base and the height. Remember, the area of a triangle is base times height divided by 2, and that's lowercase b. So you would need to know the length of one of these, basically of these 2 sides, okay? Assuming it's a right triangle. And for the total surface area, again, you add at the end this plus 2 pi r squared on cylinder. That's the same thing as plus 2 times capital B, because pi r squared is the area of one of the bases, which is a circle. In this case, your surface, the bases are triangles, so it's pi r squared. That's not what I meant to say. So it's base times height divided by 2. Pi r squared is for the circles, that's why that's in that formula. Here, prisms, the base can have different shapes, so they can't just say length times width like it would be in this one, or base times height divided by 2 like in this sandwich prism that I have added to your PowerPoint. Okay, and not to go over the steps here, I left this example in, this last example, to show you in geometry, we're going to start leaving answers like this, 24 pi. In chapter 1, they're still saying, okay, you can grab a calculator and take 24 times pi, and you're estimating. 24 pi is an exact answer. 75.4 is rounded off. I also wanted to remind you that since this is area, the units are centimeters squared, and then to point out to you, in this cone, the slant height is 5. That's what I meant by on the outside surface of the cone or the pyramid, the slant height, and that's L. So see how they color coded it green? They put a 5 there. They didn't use the height at all. That's H, 4 centimeters. You don't need the height when you're finding the surface area of the cone. You just use the radius and the slant height. The radius is 3. Okay, and for the volume of a cone, you've got that 1/3 in there. So the order of operations, you're multiplying everything. You could put it all in the calculator and push enter. But if you save the 1/3 till the end, you could just end up dividing by 3 if you're trying to do it in your head, like 9 times 4, 36 divided by 3 is 12. Also note how in the book in chapter 1, they have that as a step to show you 12 pi, because later that's going to be your final answer, because that's exact. But if you grab a calculator and push times pi, this is what the answer will round to as a decimal. And this is volume, so it's centimeters cubed, because we took 3 and squared it, and that was centimeters. So centimeters times centimeters is centimeters squared. And the height, see, this time they use the height when they get the volume. That's where the 4 came in. And then they multiplied times centimeters again. So the units on volume are centimeters cubed.